You guys know. Easiest function you guys know. Well, I shouldn't say the easiest. X squared, right? The easiest is a line. X to the first. The parent function,
Sorry, I was trying to find my
the,
pencil.
you need to dye your head. No, I'm recording. I'm not going to go off. Uh, so the parent function is my parabola, right? There's my parent function. 1, 1, 2, 4, 0, 0, right? And I've been talking about the past, actually, probably the past week, about this point here, right? What do we call it? Zero, intercept, root, solutions, right? Past couple of days, I've been really talking to you about the zeros, right? So this parabola, this function here, x squared, has how many zeros? Yeah, 1, 0, right? Um, Here's a parabola. How many zeros does this have? Yeah, this one has 2 zeros, right? And then what about this parabola up here? How many zeros?
None.
0 zeros. 0 zeros. So, what the fundamental, one of the things, I shouldn't say it's the only thing, what a big part of this fundamental theorem of algebra says is look at the degree of your polynomial, look at the degree of your polynomial, and that's how many this particular function so tells us how many zeros, roots, solutions, whatever you want to call them, x-intercepts, right? Tells us how many zeros that polynomial may contain, may have, right? Now, if we go to your note sheet here, okay, I should have this all. Okay, if you go to your note sheet here, it says we will determine all of the zeros, right? Now, it says you will find the same number of solutions as the number of degree. Now, I just told you that it could have up to that number, right? Well, as it turns out, if you include imaginary numbers, you can find all of the zeros, even the zeros of this one, right? If you include imaginary numbers, you can find the zeros of even this one. They're just going to be imaginary, right? So that's what we're going to do with our problems. So we're going to have to synthetically divide. Here's the process. We're going to synthetically divide, get the polynomial down to a quadratic, and use one of our techniques to factor it to find the rest of the zeros. So we could do any degree polynomial, x to the fourth, x to the fifth, x to the sixth. Depends on how much I want to make you guys work, right? Because each time you're going to divide it down by a zero to get to a quadratic, right? And then use one of our techniques for that we learned to factor a quadratic, right? And if all else fails, we can use quadratic formula, right? And that will give us our imaginary solutions if it has them. Okay, this other note. If you graph a polynomial and the function seems to bounce off the x-axis, that means the solution shows up more than once, called multiplicity. And let me see if I can draw an example of that. What we mean by that. Okay. All right, so I'm going to graph the function y equals, or the f of x equals y to the fourth, x to the fourth. Okay, we know it's a parabola. Okay, so it could have up to 4 zeros, but I'm going to make one of those zeros bounce off, kind of like this one, right? Bounce off the x-axis. So it's a parabola, and it has a bump, right? Okay. So it has 1, 2, 3 zeros, but we're going to say that this is a multiplicity of 2, so that it has 4 zeros. So this will have a multiplicity of 2. It could actually, well, I'm not going to confuse them. Okay, so we could have a multiplicity. And probably not today, but eventually. All right, so let's do one of these, following our little process. And you guys are going to need your calculators from here. So if you need your calculators, I would get up and grab them. And I will pause this video. All right, number one. Number one. Using a graphing calculator, I'm just reading this process. Determine an easy spot for an x-intercept, or what we call a zero. Hopefully we can get a whole number, right? So I'm going to go to my y equals, put this polynomial in there, x cubed, x raised to the cube. Now you have to arrow out of that exponent, right? Minus 4x squared. Again, make sure you arrow out of your exponent. Plus 3x. Graph it. And it looks like we have zeros here at, now we can cheat on this one, right? See, we got a 0 at 0, 1, and 3, right? We could check these because what are the y values at the x zeros, right? What are the y values? What are the y values at 0, 1, and 3?
For the X, it's 0.
For the x,
Oh,
this
for
arrow
Y.
is 0. This is, for the y, it's 0, right? So I can go to my table, heading second graph, look for my y's that are zeros, and the x values are going to be my intercepts, right? So I was right. 0, 1, and 3. So there's my zeros. Technically, I'm done with the problem, right? But we would never make you problems that easy, would we? Ever? We would want to see all your work. So I'm going to go to the second process here. Divide the original polynomial by the zero you're using synthetic division. So my dividend are going to be the coefficients. What are my coefficients? 1
-4, 3.
and a positive 3. What about my constant? What's my constant here?
0.
Thank you. I'm going to divide it by one of the divisors here. The first x-intercept, or 0, is, hey, 0. A lot of zeros in this problem. Huh? Bring down that first number. multiply it to the 0. 1 times 0, 0. Negative 4 plus 0, negative 4. Negative 4 times 0. In fact, all of these are going to be 0, right? 3 plus 0, 3, and then 0 plus 0, 0. So I started with an x cubed. So this is 1x squared minus 4x plus 3. And I need to find the other two zeros because we're going to, in this, because we're going to use imaginary numbers, we're going to find all the zeros. So I'm going to set this equal to 0, find two zeros from this quadratic. With me? Isn't this fun? Yeah, it is. It's fun with math. And it's only Tuesday. Wait till Friday when we get the Friday Fun Follies. Okay, so let's use a guess and check method, right? That's always easiest. What's the only way to get x squared? X times x, right? Um, 3 is a prime number. So how do I get 3? Yeah, 1 times 3, right? It's a positive 3, so they're going to be the same sign. Which sign am I going to use? Negative or positives? Careful. They have to add up to a negative 4.
Negative.
Negatives, good. Right? Because if you do your arches, negative 1x, negative 3x, they add up to negative 4x, right? All right, I got to find the zeros here. So what do? I just set these factors equal to 0. X minus 3 equals 0. Add 1, add 1, x equal 1, and x equal 3. So there's my zeros. Isn't this fun? And there's all kinds of things that we're going to throw in here that you guys are going to have to deal with. That's why we're going to take a few days for this. All right, number 2. Are you ready? Huh? Are you ready? Don't contain yourselves. Jeez. You guys are out of control. X cubed minus x squared plus 49x minus 49. Graph it. All right, we can get at least 1 0 out of here, huh? What does it look like it's going to be? Yeah, 1, huh? Gonna just double check here. Look at, yeah, my y, here's a y equals 0, so my x-intercept is 1. Don't fall asleep on me. All right, my coefficients, the dividend, 1, negative 1, 49, minus 49. Divisor is 1. Bring down the first 1. 1 times 1. 1. Negative 1 plus 1. 0 times 1. 49 plus 0. 49 times 1. And negative 49 plus 49. Okay, started with x cubed. So this is my 1x squared. This is a 0x to the first, right? So I don't need to put it on there. Plus 49. And I need to find two more zeros here, right? I'm down to a quadratic, so I can factor this. What's the problem here? Do I have a way to factor a sum of squares? No, right? I have a way to factor a difference of squares, but not a sum of squares. What are we going to have to use here? Yours and mine favorite? Quadratic formula, right? X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, what's my a? 1. What's my b here? What's the coefficient of x to the first? Here's my x to the first. What's my coefficient? 0, right? What's my c? 49. Good. All right, just going to substitute them in. X equals negative b, negative 0, plus or minus the square root of 0 squared minus 4 times my a, which is 1, times my c, which is all over 2 times my a, 1. Guys, remember what we did first with these? We did the square root. Or I think some of you just did what's inside and then took the square root of it. Anyway, 0 squared is 0. Minus 4 times 1 is 4 times 49. Let's see, 36. 16, 196. And don't forget the minus sign. Actually, 196 is a perfect square, isn't it? So I have the square root of negative 1 times the square root of 196. What's the square root of 196?
16.
Close. 14, right? Square root of negative 1. You guys know this. I. So I'm going to take this 14i, plug it back in here for the discriminant. So x equals, I don't have to worry about this minus 0, plus or minus 14i divided by 2. So what are my other two zeros? You could reduce this. Plus or minus 7i, right? So my zeros, x equal 1. Now, if you want to separate these, I like separating them plus 7i, minus 7i, because it shows me that I need 3 zeros. But it's more than okay to leave it as plus or minus 7i. Either one of these guys, fine. So I know it's a lot of work, and it actually gets even a little bit harder, a little bit longer. When you go up on degrees, it gets longer. Okay? And we'll do one because it's on your homework. So let's look at your homework. Let's look at number 3. Okay, this is your homework. Let's look at number 3, right? So it has the intercepts at 2 and negative 2. So x equal 2 and negative 2. So we already got 2 of the 4. We don't have to put it in a calculator, graph it to figure out one of the zeros because they give us 2. Okay, coefficients of my dividend. 1, 5, negative 4, negative 20. What's my constant? Good. I'm going to use my first divisor, 2. And here we go. Bring down my 1. 1 times 2. Oops. Is 2. 5 plus 2. 7 times 2. 14 minus 4. 10 times 2. 20 minus 20. 0 times 2. 0 plus 0. 0. Okay, so we went from x to the 4th. So I have a 1x cubed plus a 7x squared plus a 10x to the 1st. And if you want to put a 0 there for the constant, that's fine because we have to divide this again, right? I have a 1 because we need to go down to a square. So I have a 1, a 7, a 10, and a 0. My next divisor, this time I have to use negative 2. And here we go. Bring down the 1 times negative 2. Negative 2 plus 7. 5 times negative 2. Negative 10 plus 10 is 0. 0 times negative 2. 0 plus 0 is 0. Okay. Had an x cubed. We're dropping it down to an x squared plus 5x plus 0. I don't need any more zeros. But I do have a quadratic now. I can find the other 2 zeros. And I got pretty fortunate here because it's easy to factor this, isn't it? What do I do? What's the first thing on your flow charts? Factor out any common zeros, right? Any common terms. This has an x, 2 x's. This one has 1, so I can factor out an x, right? X squared divided by x. 5x divided by x. So what are my zeros here? Set them each equal to 0. And my other two zeros? Well, I got 0, positive 5. Now, this could have been a long problem when we got to here. We could have maybe had to use a quadratic formula, right? Imaginary numbers. So, like I said, every time it goes up a degree, it could possibly be a longer and longer problem. Can you guys do one problem before you leave? Oh, 1 and 2, don't make these real hard. Again, what are going to be my zeros here? Just the opposite signs, right? 1, -7, -1. That's all they're asking you.